15 over 4 times 2, so that's just going to be negative 30 over 4m. I know I could have simplified, I'm just not. And then negative times a negative is a positive. 15 times 2 is 30, and at the bottom 4 times 3 is 12. Minus 11 over 4. Okay. I am going to clear. I'm going to get rid of my denominators by multiplying everything. The LCM is 12, so I'm going to take the left side, multiply by 12, and then this guy, I'm going to also multiply by 12. 64 times 12 is 700 and something, 68. And I'm going to take 12 and multiply by each term inside the parentheses. Negative 30 over 4 times 12. First of all, it's going to be negative. And then 12 divided by 4 is 3. And then 3 times 30 is 90. 30 over 12 times 12. Well, 12 and 12 can simplify. It just gives me 30. Negative times a positive is a negative. 12 divided by 4 is 3. And 3 times 11 is 33. Good. 768 equals, let's combine these two. We get 123m, negative by the way, plus 30. We're going to minus 30 on both sides. And we get 738 equals negative 123. Divide both sides by negative 123. M equals negative 6. Right. Now comes a check. So I'm going to take this, the original equation. So 64 equals negative 15 over 4. 2 times negative 6, right? Minus 2/3. Minus 11 over 4 times negative 6. All right, so let's simplify this mess a little bit. 64 equals, and then negative 15 over 4. Inside the parentheses, 2 times negative 6 is negative 12. And negative 12 times, minus negative 2/3 is just negative 12 2/3. This is, then we have negative 11 over 4 times negative 6, so that's going to give me positive. 66 over 4 simplifies as 3 over 2. 11 times 3 is 33, and then don't forget we have to divide by 2. So 33 divided by 2, and we're going to write that. You can write that as 16 and a half if you like. Positive. 64, and then I have to multiply these two, and I am going to cheat by using a calculator, times 12 and 2/3. And that gives me 47 and a half. So if you get 47 and a half plus 16 and a half, and you'll notice that both sides equal 64, and our answer of m equals negative 6 is okay. Good. 2 trains. We have 2 trains here, and they're going towards each other, and let me put them on parallel tracks. So this train over here is going that way, and he's going at 55 miles an hour. This train over here is going this way, and he's traveling at 75 miles an hour. I know that from train A to train B, the distance here is 364 miles. Okay? So let me just tell you that at some point, well, they're going to travel for the same amount of time. So they're traveling, and you say stop. Not stop, sorry. They travel until they're nose to nose. So obviously the train that's faster travels a little bit more than the train that's slower, right? But what I want you to notice is, what can you tell me about this distance that the slow train traveled and this distance that the faster train traveled? Well, if I take those two distances and combine them, I know it's going to be equal to 364 because that's what they told me earlier. So I know what my equation is going to be. Distance of A plus distance of the second train equals 364. Well, we got to figure out what the distances are. So RTD, R rate, time, and distance. And remember, distance is a product of rate times time. So the slower train, he's at 55 miles an hour. That's his rate. The faster one is at 75. Time, they both travel for a certain amount of time, same amount of time. Distance, remember, distance equals rate multiplied by time. So we multiply these two columns and we get 55t. and the other one is 75t. So distance of the slow train is currently represented by 55t, and this is of the faster train represented by 75t. Let's combine like terms. So we get 130t equal 364. We're going to divide both sides by 130, and we can definitely simplify this. T equals 364 over 130. That's going to give us 2 4/5 of an hour. So both trains traveled for 2 hours and 4/5. Think about it. An hour divided by 5 is 12. So, and 4 times 12 is 48. So both trains traveled for 2 hours and 45 minutes. And at that point exactly, they were right here, nose to nose. If you wanted to find the distance, if I ask for a distance, maybe I will. First train, let me write it here. 55 miles times the time, which is 2 4/5. So, which I'm actually going to change that. 5 times 2 is 10 to 14 over 5. So just make it easier for me. Right, so 55 miles an hour. For how long did that train travel? For 14 over 5 hours. Let's multiply these two. 55 divided by 5 is 11. 11 times 14 equals 154. So the slow train, his distance was 154 miles. While the faster train, his speed was 75 miles an hour. Let's multiply that by the time. Right? So 75 divided by 5 is 15. Times 14, that gives us 210 miles. Now, if you add 210 and 154, do you get 364? Yeah, you do. So we are good. Let me try drawing this again. Here's a river, and Heather is over here right now, on the dock. She's going to take the boat, and then she's going to take the boat and she's going to go up the stream. And she's going to turn around and go back to the dock. One thing we can tell right away, that this distance here, and let me change colors, and this distance, right? She's going to go up a certain distance, turn around, and bring the boat back to the same exact spot. So we know that the upstream distance is equal to the downstream distance. Now notice that this is a question dealing with a river, and if a river has a current, in this particular one there is a current. Okay, they say that the current is moving at a rate of 3 meters per second. So when she's going upstream, although Heather can paddle at 7 meters per second, she's going against the force, which is going to obviously decrease the speed. So in this case, it's going to be 7 minus 3 meters per second. So her net speed is going to be 4 meters per second. So actually, when she's going up, she's going at 4 meters per second. Now, when she's going downstream, though, it's a different story, because now the current is helping you and it's making you go faster. So her speed is 7 meters per second. We're going to add current to her speed. So her net speed is going to be 10 meters per second. So she's going to be traveling much faster. That's pretty much all the information we need. All right, back to our table. Up, down, R, T, and D. All right, so up the stream, she's going. Remember we talked about it's 4. Down, she's gonna be faster, so it's gonna be 10. Time, now time you have to be careful here. It's meters per second. So time in this particular problem is in seconds. So we know that the whole traveling, the whole up and down, all this, she went up, turned around, came back. It took her 5 minutes. So 5 minutes is the same thing as 300 seconds, right? 5 times 60, 300 seconds. So that's where you have to be also careful. So we don't know how long it took her to go up, and we don't know how long it took her to come down. So it doesn't matter which leg you call it. One of them you call T. And the other one is going to be 300 minus T. That's it. Now the rest is easy. 4T distributed property, 3,000 minus 4t, sorry, minus 10t, right? 10 times 300 is 3,000, 10 times t is 10t. We know they're equal to each other, so 4t equals 3,000 minus 10t, plus 10t on both sides. We have 14t equals 3,000, so the time, we're going to divide both sides by 14. It's going to be 3,000 over 14 of seconds, right? So if you were to round, or change that to a, let's change that to a decimal. It's going to be about, rounded, 214.28 thousandths of 29th actually, rounded. Okay, so going up the stream, you took our 214.29 seconds about, and you can tell that downstream, if you subtract 300 minus 214, it's going to be a much shorter time, and like we said, because she's traveling with the current. Now, distance-wise, well, let's multiply. Well, let's take this guy over here, distance, right? Distance is both the same for up and down, so you could have used this expression as well. I'm just going to use the easier one. So 4 times. Now, in this case, we can multiply by 3,000 over 14 or the decimal. Let's just keep it as the fraction, and then we can change it. So 4 times 3,000 over 14 gives us roughly, well, as a fraction, we can write it as a fraction, 857. Uh-oh. My pen. Here we go. 857 and 1/7 meters. Okay? And that's the distance. All right, so things you have to be careful with in this question: going against the current, going with the current, and the time here was not. If you wrote 5 minus t, you would have gotten probably the incorrect answer, right? Because it's in seconds, not in minutes. Okay? That's it. No. All right, here we go. We have, this one's a little tricky. Well, same thing as the upstream, downstream question. Not tricky, just extra work. All right, so we have a plane. Plane is the same thing, going north. And what do I know? It takes 4 hours to go north. And the speed is r. I don't know what the speed is. But on the way back, notice that it takes 3 hours and 18 over 60 minutes, which means we have a wind helping him, right? So the speed is, wind speed, speed is 40. So his speed, his total speed would be r, the speed of the airplane, plus the speed of the wind, okay? Right? The speed of the airplane plus the speed of the wind combined would be his total speed. So you need to understand that. That's, I think, just like the number 9 with the stream. I mean, next time you go to a river somewhere where the current is not too strong or very manageable, try going up, swim up the stream, and then try swimming downstream. You'll see a considerable difference. All right, so let's set the table. Erase this part. So, so we're going north, and we're going south. Our TD, and I hope you notice that the distance that they travel are equal to each other, right? Right? We're traveling the same distance, just different direction. So going north, I don't know what the speed of the airplane is, but I do know the time is 4 hours. Going south, the speed of the airplane is r plus 40. Sorry, going north is going to be r minus 40. Okay, because you're going against the wind. Time-wise, going back, I know, and I'll write it as 3. Let's see, we can simplify this by 6, 3 over 10. I don't know if that's going to help. Now, we do our distributive problem to find the distance. So distance would be 4 times r, which is 4r minus 160. Let's multiply 3 and 3/10 times r. It's just 3 and 3/10 r plus, I'll take the calculator here, 40 times 3, 3 over 10 times 40. That's times 40. That's going to give us 132. Right? So now I know the distances are equal to each other. So okay, 4r minus 160 equals 3 and 3/10 of it r plus 132. We have, let's get rid of this 160 first of all. Actually, let's get rid of variables on both sides. Sorry, I'll leave it like this. So I'm going to do minus 3 over 10, 3 and 3/10 r minus 3 and 3/10 r. So if you think about it, that's the same thing as 4 minus 3.3. So that's just going to leave us with 7 over 10 r. Yeah, minus 160 plus 132. 7, sorry, I gotta do plus 160, plus 160. That's 292. That goes away, 7/10 of r. We divide both sides by 7 over 10, which is the same thing as multiplying by 10 over 7, right? So this all simplifies to r, and over here, 292, does that divide nicely? 292 divided by 7, and it doesn't? It doesn't. So let's leave r as, let's see, 292 times 10. I'm going to leave it as at least a pretty 292, 0 over 7. As 417 and 1/7 r. Miles per hour. So the speed of the airplane without any wind is 417, 1 over 7 miles per hour. I think that's it. Is there any more? No, I think that's it. Yep.